We've already configured VRFs, IPsec, and GRE, but now we need to do a little bit of troubleshooting. Stay tuned right here on IT Pro TV.
You're watching IT Pro TV.
It is time to troubleshoot some path virtualization, and here, of course, to guide us through that is Anthony Sequeira. All right, Anthony, we've talked about some of these different technologies in path virtualization, so where are we going to pick up in troubleshooting?
Let's tackle a couple of concepts here. One of them is on VRFs. It occurred to me when we were discussing those, Ronnie, we didn't really talk about where we might run into virtual routing and forwarding.
Right.
We stressed when we covered VRFs that we're going to forget when troubleshooting them time and time again to reference the VRF. Remember, like ping, and it's not going to work, and you're about to panic, and then you realize, oh gosh, I need to tack on the VRF keyword and the VRF name to get this ping to work. I wanted to, in this episode on this topic, go to a higher level and think about the C, the CE, the PE, and the P routers. What are we talking about here? Well, there's a customer router, a C router. And is that going to have any knowledge or awareness of this fancy VRFs?
No.
Nope. There's a customer edge router at the edge of their business or network, right? And it's going to make a connection up to the provider. Does it have any VRFs or anything fancy? No. So just a reminder here, you'll see people troubleshooting in an MPLS environment, for example, and they're like looking for VRF stuff on the customer devices. It's not going to be there. That's part of the beauty of this, is that we're not putting any burden on technology or overhead on the customers. They're just doing the standard old routing that they're used to doing. When we get to the provider stuff, that's when we can get into the VRFs. So a classic place is your provider edge is going to have VRF set up, and that's where you want to do a bulk of your troubleshooting. So just kind of a reminder there about how the VRF structure is going to work. Now, we talked about GRE and IPsec as path virtualization technologies. You often get them combined with each other because you'll have some form of traffic that isn't supported, so it's encapsulated in GRE. Multicast is often found itself inside a GRE to be transported over environments that don't natively support multicast. And then, of course, GRE doesn't give you any security, so you end up wrapping it up in IPsec. What's happening? The packet's getting bigger and bigger and bigger as we're encapsulating it with all this stuff. I wanted to remind you, we didn't talk about this. The IP datagram, of course, there's a maximum size for that, but that's not the issue. It's the fact that there's an MTU on links, and it is typically set to a much smaller value than the IP datagram max size. In fact, we know when we get up to roughly 9,000, we're talking about a jumbo frame is how we describe it. So one of the things that you can get into is a lot of fragmentation thanks to this additional overhead of information that you're encapsulating on your IP information. So I want to do a little discussion here of fragmentation with you. Remember, IPv4 fragmentation and reassembly is made possible thanks to the v4 source and destination, an identification field in IPv4, the total length field, a fragment offset field, and that should be field singular, not fields. And then the more fragments and don't fragment flags. Remember, there's a flag, there's a 0 or 1 bit to indicate, hey, there's more fragments coming, and there's a 0 or a 1 bit to indicate whether or not this information can be fragmented. So a lot of information there, but that is the information that dictates whether we are going to be fragmenting, and if we're fragmenting, how that is going to work. Now, to avoid fragmentation, why do we want to avoid it? Well, it places additional overhead and complexity on the whole thing. Oftentimes you'll have interfaces that they may have the necessary compute power to be moving traffic, but they're struggling because of the amount of fragmentation and reassembly that they need to do. There's actually a Cisco technology where you can have interfaces that aren't as busy, neighboring interfaces, help with the fragmentation and reassembly. It's like, hey, we'll all pitch in. So pretty interesting. But understand, it's nice to avoid it altogether. And please know these two technologies for your Encore exam. There's something called the TCP maximum segment size, and this is really a nice built-in solution. Your hosts that are transmitting back and forth to each other, they look and they go, oh, okay, well, you know what? We'll just set a smaller size for the chunks of information we're going to be communicating with each other so that it doesn't exceed the link's MTU and there doesn't need to be fragmentation. But alas, there is one problem with this approach, and that is the fact that they are not aware of all of the links between themselves. So the host A, in this example, it knows the maximum size that it can use on its link that it's connected to. The far away host B has the same information. It can get information about its link, but they don't know about all the links that might be in between. And that's where you have PMTUD technology, which is the path maximum transmission unit detection. I believe that stands for. In fact, Ronnie, if you don't mind looking up PMTUD, you know me. One of the things I struggle with is remembering the exact acronym meaning, but I think it is Path MTU Discovery. What this feature is doing, as its name implies, is it is going along the full path, and it is alerting us to MTUs that might be set smaller than something like the MSS in a path. Well, I did it right, didn't I? It's
yes,
Path
you did.
MTU Discovery.
Right.
Great. Got lucky on that one.
Yeah.
So this is a big deal. And understand that here's how here's how that's going to work. What happens when we combine this GRE encapsulation in these tunnels with this concept of fragmentation? Well, I laid it all out here for you. You could make flashcards on this. What's going to happen is first, there's going to be a check whether the DF bit is set, right? So your tunnel interface is going to be like, oh, well, okay, can I even fragment this? Is this permitted to be fragmented? That's question one. Obviously, if the answer is no, it can't be fragmented, it's either going to be dropped or encapsulated and sent. The next thing is check what size, obviously, the tunnel can accommodate. So if it's been set up so that it can potentially be fragmented, that bit is set that way, then the packet is assessed against the packet size for the tunnel, and then you're going to have one of three things occur, notice. It's fragmented because it's too large for the tunnel transmission and the DF bit's not set. So what's going to happen? Well, it's going to fragment it, and then it's going to GRE encapsulate each one of the fragments. You get a sense for why we wouldn't want to do this. You just increase the overhead on this situation. And that's the first option. That's fragmented, encapsulated, and sent, those fragments. The second option, of course, is it's going to be dropped. It's too big. That it gets dropped if it's too big or the DF bit set, right? So it can't be fragmented. And then an ICMP message, of course, is going to be sent to the sender that says, just had to drop your packet, sorry. And indications of the inability to fragment can be encoded in the ICMP. And then finally, it could be encapsulated and sent. So understand, fragmentation tends to be the enemy. We are increasing the chances that we'll need fragmentation when we do these fancy path virtualization technologies that add additional length to the datagrams because of the encapsulated information. And we also talked about in this episode, just how there are techniques like MSS and PMTUD that are there to try and assist us. And Ronnie, we also took a look at the top of this episode, of course, was the old VRFs. Don't get in the embarrassing situation of looking for a VRF on the customer edge device, because it won't be there by definition.
All right, Anthony, thank you again for helping us understand more about the basic things that we want to make sure that we keep our eye out when having to troubleshoot things like VRF as well as GRE tunnels. These are key elements that you want to take some time, slow down, and use different show commands that you can actually spot some of the elements that Anthony's been talking about. But there is a lot more to come, but that's enough for this episode. So signing off for IT Pro TV, I'm your host, Ronnie Wong.
And I'm Anthony Sequeira.
Stay tuned right here for more of your CCNP Encore show.
Thank you for watching IT Pro TV.